Alright, so in number 10, we just solved a problem where all of our potential was turning into kinetic. And we set those to equal to each other, and since mgh would equal 1/2 mv squared, rearranged this, we canceled out the mass and solved for velocity and got square root of 2 times the acceleration due to gravity times the height, square root of 2gh. So if that's true, now in number 11 it's asking us to consider a pole vaulter. So it has to clear a pole, and there's my pole vaulter, there's my pole anyway, of 4 meters high. So how fast does the actual pole vaulter need to be running, or, and kind of rephrase that question, what kind of kinetic energy does this person have to have in order to get enough potential energy to actually get high enough to clear that? Alright, so in this case, all of my kinetic energy needs to equal all of my potential energy. Now I can do the same derivation again where I set, potential energy is mgh, 1/2 mv squared, but I've already done that here. So I can say, because of what I found last time, that my velocity, since this is true, I'm going to say since Ke equals Pe, kinetic energy equals the potential energy, because all of it's being used to get over that bar, I know that that is true, because I just solved for that. So the square root of 2 times the acceleration due to gravity times the height. So all I need to know is the height, and luckily I have that. So the velocity necessary to acceleration due to gravity is 10 meters per second times the height, which was 4 meters. So velocity is equal to, 20 meters per second times 4 meters. Velocity is equal to 80, square root of 80 meters squared per second squared. So now we have the square root of 80, which honestly off the top of my head I don't know, and I don't have a calculator within reach, so I'm going to let you calculate that on your own, but whatever the square root of 80 would be, and I'm going to ballpark here, 64 would be 8, 9 would be about 80. If it was 9 meters per second, it would be about 81, because 9 times 9 is 81, so I'm going to ballpark here. It's approximately 8.9 meters per second, roughly. Double check me with the calculator, but now we have our velocity. And I knew that because I knew all of this kinetic energy here that this person is running with, launches in there, puts their pole right in there and launches themselves upward. All of that kinetic energy has to turn into potential. So if that's true, I set one equal to another. I end up solving for velocity, which we did up here, and get square root of 2gh. Plug in your numbers, 8.9 meters per second.